Hello, and welcome to the third section of our course, Introducing LINQ. In this section, we'll introduce LINQ, the language integrated query, by jumping straight to some code. We'll talk about the types func of t and action, and their derivatives. We'll also talk about the lazy LINQ and what does it mean to have lazy code. And finally, we'll take all that and try to use it to implement a new feature of our Books app. With that, let's start with creating your first LINQ expression. In this video, we'll jump straight to code and we'll demonstrate the power and ease of use of LINQ methods. Then we'll talk briefly about the logic behind LINQ and the types func of t and action. With that, let's jump straight to some code. Now we're back where we left our code, and I would like to draw your attention to the method author is already cataloged. It has quite some lines of code in it, and I want to make it a single line of code. And there you go. Using LINQ, I've instructed it to take the books by author catalog and tell me whether or not there are any books and authors that have their author equal to the author that we passed in. That method now is a single line of code and returns exactly the same as before. Similarly, if we take locate author already cataloged, we can change it a bit to look a lot like this one, but instead it will not return int, but will return an instance of books by author. You do that. Let me get rid of this code and start with a return statement. Again, I begin with the books by author catalog and use one of the extension methods that's called first. So basically I'm telling, okay, give me the first item of this collection that will satisfy the predicate that I will now enter. Again, the predicate is similar like the one before. Give me the first item of this collection that satisfies the predicate that it has an author equal to the author that we've passed in. You may have noticed that we have some red squigglies right here. That is because we are no longer returning an index from the locate author already cataloged. Rather, we are returning the author and their books. Rather, we're returning the author and their books already. So we can rename that to, if I can spell correctly, author and books. And again, we don't need this line of code. The author and book already gives us what we need, their books, so we can directly add one book to that. And that's it. Our code compiles and runs just like before. And there you go. Alright, let's talk a bit about the func and action types. A very important feature of C# are the delegate types func and action. These represent a method, or to be more precise, they represent a function. And the difference is that a method is always attached to a class or an instance of a class, while func and action can very well be a variable type or even a return type. Yes, we can return functions as results of other functions, and we can pass in func of t or action as parameters of other functions. Func of t represents an expression that receives no arguments and returns t. Func of t is a function. Action represents an expression, a function, that takes no arguments, does something, but does not return a result. Similarly, func of t, r takes type t, or I should say it takes a parameter of type t and returns a result of type r, while the action of t takes a parameter of type t and does not return anything. What happens inside is purely the concern of the actual implementation. I want a second here and talk about func of t, action of t. These are all generic types, and a generic type we can think of as a parameterized type. It can accept a number of other types in order to make it complete. It should get clearer as we show the code. So we're back in our code. We have this demo func class, and right on top we have this int func. It's just a field of the demo func class. After that, there is a method that returns a func of t given some input, and there is the exec method, takes in a func and returns an object of type t. What it does is just simply execute the function, evaluate it. So let's get down here to this contrived method. This hello world func is actually the result of calling the asFunc method up above and giving it the hello world. So in effect, this is a function that will return hello world. If we execute it using the other method, exec, we'll get hello world back. Basically, hello world equals the string hello world. Similarly, if we give it as func of 1, we get a int func, which executed gives us 1. It's a bit contrived thing, I know. Let's show something a bit more realistic. So right here may seem like a lot, but I'll try to take it slow. Bear with me. In here we say, okay, I want to define a function which takes in an enumerable of books by author, a collection, takes in string, and finally returns a boolean. If that sounds familiar, you're right, yeah, that's the author exists from the previous section. So in here, we define the input parameters, books by author, that's the enumerable, and author name, that's the string. And what we do is just simply call the any extension method and ask, are there any items in the books by author collection that satisfy this predicate? Basically, their author is the same as the author's name. And this whole thing here is called the lambda expression, and it represents a func also. Let me show you the signature of any, and it might be a lot to take in, but again, any takes a func of books by author and return bool predicate. Down below, similarly, we want to get cataloged author. That function will receive an enumerable as string and will return books by author. So we get books by author, an author name, and we ask, okay, books by author, give me the first or default item that satisfies this condition. And this is a version of the first method, first or default, which does not throw exception if it doesn't find any item that satisfies that predicate, while the first method is more strict that way. It will throw an exception if it does not find anything that satisfies the predicate. And you see down below why we need it. I've created an empty enumerable of type books by author, and I've evaluated author exists with it, passing the books by author and Homer as author. This exists will be false because this is an empty collection. Similarly, get cataloged author will return no because there is no cataloged author in an empty collection. Alright, so much for func. Let's go to demo action class. Similarly, I've created a field of type action, also a function which returns an action, and it's really a contrived one. It's just creates an action that will just write line the name of the type that we pass in, or when we try to use it, we give it as action of type string, and this creates a action that will take string. So we called it, basically will take string, takes a string, and prints out the type string. Similarly, we have type safety, or the red squiggly below. It says argument 1 cannot convert from int to string. So it knows that we'll take string, accepts only string in, and we'll fix it by making the one a string. Down below I wanted to show that the action and the func similarly can take quite a bit of parameters. This takes a string, this takes int and string and does stuff with it. This takes any object, and this is the longest action that you can use. It takes 16 parameters. That's the maximum. If we add another, as you can see, immediately there's a squiggly. So we cap out at 16 parameters, but don't worry. I've never had to use so many parameters until now, and I don't think I will ever have to. With all that, I wanted to show you what the func and action types are. In practice, they are mostly used inside the LINQ extension methods, or more precisely the IEnumerable extension methods, but more on that later. And I think some level of understanding of func and action will come in handy. Now, there are more details like func and action can hold more than one func or action inside of them, and such stuff, but we'll not get into details like that in here.